Welcome everyone to Zahid's data mining channel once again. Sometimes you may have a data set that can have some values incorrect, incorrectly recorded, noisy, or also known as corrupt data. And also sometimes you can have a data set that may have some values missing. So values are not collected, records are not collected. So how do you handle situations like this? Today, I will demonstrate a software tool or a couple of software tools to deal with this problem. We published a paper called CAIRAD that can actually automatically detect a corrupt value. So if you go to my web page on Google, then go to my personal web page, and then if you go to my publication list and write CAIRAD as a search option, you will see the paper that we published on corrupt data detection. The preprint of the paper is freely available, and there are YouTube videos as well. And if you go to my code section on my web page, then you will see the code for CAIRAD is available. You can simply download it and then use the downloaded zip file in Weka to use this technique in Weka. Weka is a freely available software tool for data mining and data analytics. There are lots of techniques there, and you can go to Weka's tool options and then package manager in order to install CAIRAD on Weka. On the Weka package manager, you have two options. Either you can search for the technique CAIRAD that you have just downloaded from my web page, and you go to your folder, browse there, and find the zip file, and then install it, download it, and install it. Or you can search for CAIRAD here and search for it and find it from Weka directly. But before you do that, you need to refresh your repository cache so that you have CAIRAD in Weka. So once you have clicked on the install button and installed it, you will see CAIRAD installed there. It is recommended that after installing CAIRAD, you restart Weka. After you restart Weka, you can go to the Explorer page, and you need to now upload the dataset that you want to see whether it has any defective value or not. You can upload the dataset. I'm uploading a dataset that has some defect. For example, I have created a toy dataset called toy example corrupt.arff. ARFF is the extension format for Weka. ARFF files have some header information about a dataset, that's all. And my previous videos have explained ARFF files in details. Now in the dataset, this is the data, that's the toy example corrupt data. And I don't know, I have only access to this data. I don't know whether some of the values are corrupt or not. And if yes, which value is corrupt, which values are corrupt, I have no idea. So this is the first record, this is the second record in the dataset, etc. Now, for the demonstration purpose, let us assume that I also have access to the ground truth original data. And there I can see the very first value of the first record was MS, but the dataset that I have access to has value PhD. So that means this first value is corrupt, but at this stage, I would not know that. Let's use CAIRAD on Weka to identify this corrupt value. Now I can do that from the open file and go to and browse the open file, my folders, and then go to the folder where I have this dataset, toy example corrupt.arff, and upload that data. So once I have uploaded the data, if I click on the edit button, I can actually see the data. So this is the dataset, and I can see that the very first record is PhD, whereas I know in the ground truth original dataset, the very first value was MS, but the dataset that I have access to has PhD. So this value is corrupt, but a user would not know that. Now he can actually choose the corrupt data detection technique, CAIRAD, after he has installed that in Weka, as I have shown before, through the filter options and go to the unsupervised filters, attributes, and he will see CAIRAD there. So choose CAIRAD, and CAIRAD has some parameters. This parameter value, if you put it low, the lower you put, CAIRAD will have a tendency of picking more values as corrupt. And for this one, the higher you put, CAIRAD will have a tendency of picking more values as corrupt. The details of these parameters can be seen, are available and explained on the paper. As I have told you before, if you go to my web page, on my web page, click on my publication link and search for CAIRAD, then it will take you to the reference of the paper, and the preprint you can directly access. The paper I will show you here. The paper has detailed description of the technique, how the technique actually works, what it does, and the various parameters that it uses. This is the tau parameter and this is the lambda parameter, and how they influence your imputation or corrupt data detection. So now for this demonstration purpose, I am putting these parameter values 0.5 for both of them, and you can play with these parameter values to see like which parameter values can give you the best results. And after that you click OK. But generally, if you are aggressively wanting to find all possible corrupt values, then you would put a low value for this parameter and high for this one, and vice versa. So after you have chosen a parameter value, you can click OK. The data set is uploaded. CAIRAD has been selected. Now all you need to do is just apply, and CAIRAD will automatically identify corrupt values. At this stage, if you click on the edit button, the edit option, you can see the data set after corrupt data detection, and you can see that it has successfully identified this first value to be corrupt. Now at this stage, if you like, you can save this data set, and you can save this as corrupt detected, and after you save it, the data set will be there. So this data set was not there before, and now you can open and you can have this data set in your hard disk. Another option, there are some options as well. So if I undo and see the data set has been undone, so this is the original data set that you have access to. And if you go to the options, you can see that make noisy missing. If you make this option false, click OK, then apply CAIRAD again, and then want to look at the data set, you will see that now it has not identified any value to be corrupt, but it has inserted a new column here that says true and false. True means this record has some corrupt value in it, and false means these are the other records, it did not find any corrupt values there. However, we have saved the corrupt data detected file there, and if we go to that file, this was the file, I called it detected, and if I open this file in WordPad, I can see that the very first value has been identified to be missing as a question mark. That means this value is missing. This was the value that it found corrupt, and it has actually made the value missing. Now you may then, your next course of action can be to impute this missing value. You can also have some missing values in a data set anyway. But when you identify some corrupt data, this corrupt data detection technique automatically puts them as missing, and you can then impute them to get the actual value. In order to do that, you will need to upload this new file that has the corrupt data detected in the Weka Explorer. So this is that file, corrupt data detected. You upload that file, and then for missing value imputation, we have another technique already implemented in Weka, and you can download that technique, install that technique the same way you have installed CAIRAD, and the technique is called DMI. So you can choose that technique DMI now for the imputation purpose. if you again go to my web page, you will see at the moment this is the paper number 33 that was published in Knowledge-Based Systems. You can directly access the preprint. There are YouTube videos on how to download this system, etc. And I can show you the paper briefly here. So this was the paper published in Knowledge-Based Systems that explains this technique called DMI and a subsequent technique called SMI. Now, if you go to the code section on my page, then you can also download that DMI technique, and full reference to the techniques are there, bibliographies are there, 2 papers actually published on DMI. You can download the code, and also you can use Weka package manager again like before to search for DMI and find it out and install it. I have already installed, that's why my search result did not find it, because I found it, installed it, and it's in my installed list. Now, after you have installed, you can open the DMI. We have uploaded this new corrupt file, and I have uploaded DMI, and all I now need to do is just apply DMI on this dataset. So before applying DMI, if I look at the dataset through this edit button, I can see, yes, that value is missing. Now I'm applying DMI, and then if I open the dataset again, I can see that the value is not missing anymore, and the imputed value is MS. Now, if I look at our original dataset that I had access to, the value was PhD. So the corrupt data detection technique has first identified that this data is corrupt, identified this data as corrupt, and then the missing value imputation technique called DMI has identified the value should be actually MS. Now, if I look at the original ground truth dataset that I had for demonstration purpose only, you have seen that the original value was actually MS. So through this corrupt data detection and missing value imputation, you can identify corrupt values and then convert them as missing values, and then use the missing data imputation technique DMI, and then impute the original value, which is correct in this case. Just to let you know that this is a carefully prepared examples, and the parameters that I have chosen, that's why the values are correctly identified and also correctly imputed. In real life, that may not be the case all the time. So our techniques have very good accuracies in both identifying corrupt data and imputing missing values, but there is no guarantee that it will be always 100% correct. So you need to be very mindful of that. Thanks for watching.